afternoon, guys. So in section 5.5a, we talked about how you could use logarithms to solve exponential equations. Now we're actually going to go the reverse way. We're going to be looking at questions that already have logarithms in them. We're actually going to be changing those to exponential form, okay? So just like we talked about at the very beginning of this chapter, logs and exponents are inverses. One solves the other, okay? So the first thing I want you to notice, let's say I look at example 6, and it says solve the equation log base 3 of x equals negative 2. So what's a quick way for me to solve this? Well, I can take this equation and change it to exponential form. And the way that I do that is to identify something first. Identify what number is by itself. Negative 2 is over here by itself. That's going to be my exponent in the equation. Okay? So when I write this, I'm going to have 3 to the negative 2 equals x. And again, whatever it's by itself will always be your exponent. The 3 and the x are just written in the order that they appear. Okay? So what we find out here is that x is equal to whatever 3 to the negative 2 is. Well, 3 to the positive 2 is 9. What that tells me is that 3 to the negative 2 is 1 over 9. And then you're done. Okay, and you can always type that into Desmos if you want to. You can do 3 to the negative 2. It'll give it to you as a decimal. If you want to change that to a fraction, click that little fraction button right there. Okay. Example 7 here. So example 7, you've got two logarithms going on, okay? And I want to remind you of something before we do any kind of changing to exponential form. Remember that multiplication and addition pair up together, and remember that division and subtraction pair up together when you're talking about logs and exponents. So the first thing I'm going to do is I'm going to take these two logarithms that are separate right now, and I'm going to go ahead and put them together, okay? How do I do that? Well, I see a plus sign in the middle of them. Addition pairs up with multiplication. So if I want to put these two logarithms together, here's what it would look like. I'm now just going to have one log, and I'm going to take their arguments, so the x and the x plus 3, and multiply them together, so that I have now x squared plus 3x, and it still equals 1. Okay? Now that I've got these logarithms together, now I'm going to do exactly what I did on example 6, okay? I'm going to take this thing and put it in exponential form. Well, here's the thing. This logarithm had a little 3 right here. If there's nothing written here, if there is no base, what's understood to be there for a regular log? Well, it's 10, okay? So what you actually have here, and I'll write that in just so you can kind of see it there. It's an understood 10. You have three different pieces here. You have a 10, you have an x squared plus 3x, and you have a 1. Which one of those is going to be my exponent? Well, it's the one that appears by itself. It's the 1. So when I rewrite this equation in exponential form, it's going to say 10 to the first equals x squared plus 3x. So the 10 and the x squared plus 3x were written down like normal. It's the 1 that became my exponent. Well, what is 10 to the first? It's just 10. So you have now 10 equals x squared plus 3x. Well, this is a quadratic. How do I solve that? Well, my first instinct says, well, try to factor it. So I say, okay, let's set this equation equal to 0. So we have 0 equals x squared plus 3x. And now that minus 10 is on the end of it. Can I factor that? Are there two numbers that multiply to negative 10 and add to 3? Yes, there are. Positive 5 and negative 2. Okay. So when I rewrite this, if I factor it, that is x plus 5 and x minus 2. Okay. So what are my final answers here? Well, I have two of them. One of them is x equals negative 5. The other one is x equals 2. Now, here's the thing. Remember earlier in the year there were times when we had to double check our answers to make sure they didn't give us an error. If you try to plug negative 5 back into this equation, it does not give you 1, it gives you an error. That's because you can never take the log of a negative number. So even though I got two answers, how many answers do I actually keep? Only one of them. I only keep the positive answer that I got there. So your final answer is just x equals 2. Okay? All right, let's look at example 8. So example 8 is, again, got two logarithms, which means I'm going to have to try to put those together before I do anything else. So how would I go about doing that? Well, I see a minus sign in the middle of them. Subtraction always pairs up with division if I'm talking about logarithms. So in order to put those logs together, I'm going to divide their arguments. So the 2x minus 1 and the x minus 4. So that would look like this right here. So 2x minus 1 over x minus 4. And that whole equation was equal to 2. Okay? So step 1, if I have more than one log, is always to put them together. Step 2 now is to take this and change it to exponential form. Get rid of that log. Well, how do I do that? I have to identify what my exponent is. What is by itself? 2 is by itself. So 2 is going to be my exponent. So when I rewrite this, it's going to say 3 squared equals that fraction, 2x minus 1 over x minus 4. Well, what is 3 squared? That's 9. Okay. 2x minus 1 over x minus 4. And now, this is a problem that I know every one of you can solve. To solve for x, my first step is to take this x minus 4 and multiply it on both sides. Okay? So what do I end up with? I end up with 9x minus 36 equals 2x minus 1. And at that point, all I have to do is combine like terms. I can put the 9x and the 2x together. Let me scoot this up here. So that becomes 7x. I can put the negative 36 and the negative 1 together. That becomes 35. And what is x? Well, x in this case, that should have been a 35. X in this case is just 5. And then you're done. Right? All right, couple more examples. So example 9 is going to work almost exactly the same way. There are a couple differences here. First thing I want to do is go ahead and try to get these natural logs together if I can. Okay? So I have here a minus sign in the middle, which means I'm going to end up subtracting. Or excuse me, duh, you know you subtract. You're going to end up dividing when you put these things together. So natural log of 4x plus 6 over x plus 5 equals natural log of x. Here's what just got really, really nice about this equation. You have the exact same thing on both sides. You have a natural log. Well, what happens when you have two things on each side of the equation that are exactly the same? Well, they cancel each other out. So all that you are actually solving in this case is just 4x plus 6 over x plus 5 equals x. Those natural logs canceled out. Well, how do I solve this now? Well, I start by getting rid of this fraction. I multiply both sides by x plus 5. So I have 4x plus 6 equals x squared plus 5x. Okay, so this is a quadratic. How do I always at least attempt to solve quadratics? Well, I try to factor them. So the first thing I'm going to have to do is set this thing equal to 0. So 0 equals x squared. Put my x's together, and I get positive x, and move the 6 over. So can I factor that? Are there two numbers that multiply to negative 6 and add to 1? Yes, there are. What are they? They're 3 and negative 2. So when you factor this, here's what it looks like. Okay. There's my factors. What are my solutions? Well, I get two of them. X is negative 3 and x is 2. But here's the thing. Remember back up here at example, let's see, that was example 7. When we got two answers, what did we have to check? We had to make sure that both of them actually gave us a true statement. Well, here's the problem. If you plug in negative 3 for x in this equation, it will tell you error, because you cannot take the natural log or any kind of log of a negative number. So even though you got two answers, you only actually keep one of them. Your final answer is that x equals 2. Okay? All right, very last example. I'm only going to show you one thing different than really in the last section 5.5a. So here's the thing. With this example, can I do it by hand? Yes. Is it the easiest way? No. So here's what I would suggest you do when you see big long equations like this where you've got e to the something or other, bunch of different stuff going on. If everything is not on one side of the equation, go ahead and make it equal 0. So my first step here is to make this equation say e to the 0.5x minus 2.08x. Then I'm going to type this one in Desmos, negative 7.3 minus 6.2. That's negative 13.5. Okay, equals 0. I'm going to go ahead and set that equal to 0. And just like example 5 in the last set of notes, the easiest way to solve this equation is not by hand. It's to graph it and find where it intersects 0. So I go to Desmos, I type in e to the 0.5x minus 2.08x minus 13.5. And I'm going to look and see where this intersects 0. And it looks like it does twice. Here's one of them over here at negative 6.471. And the other one is over here at positive 6.61. And there's my two answers. And again, guys, if you want to see how to do that by hand, I am happy to show you. It's just, to me, it's not an efficient way to solve that equation. All right, so there's section 5.5b in all its glory. Go ahead and get started on my math lab, and please let me know if you have questions.